I'm Steve Smith. I'm probably not the only Steve Smith you know because it's a really generic name. So online, I also go by Ardalis because it's usually a more available username. And I started using that as a gaming name, and then it just kind of stuck. So you'll find me at Ardalis on Twitter, or ardalis.com is where my blog is. I work for Nimble Pros, which is a small consulting shop, and we help companies write better code faster. So if your company could use some training on any of the topics that I tend to talk about, feel free to hit us up. We're going to talk about clean architecture this morning, which also goes by a lot of other names. And I mostly work in .NET, so we're going to talk about it in the vicinity of ASP.NET Core, the latest version of which is 6. At some point, they may drop the core and call it ASP.NET again, like they did with .NET, but it hasn't happened yet, so it's still got core in the name. And if you want to learn more, I have some stuff on Pluralsight. The most relevant thing would be the Domain-driven Design Fundamentals course, which I did with Julie Lerman. And we use this architecture for all the samples in the course. And so that has a way over-engineered example than you would typically need for a course that involves like 3 different applications talking to each other over message queues and all of them using clean architecture and stuff. So if you want to see all that, even if you don't have a Pluralsight subscription, you can get the code off my GitHub repo, which is also /Ardalis. I also have a free ebook that I published a while ago for Microsoft. You can just download it. It's this one here. I'm not going to read the title to you because it's a paragraph long. I didn't make the title. And so you can grab that, and it kind of talks about how to build applications using this architectural style also, as well as some DDD principles and object-oriented principles. And I also do mentoring through devbetter.com. We have a great group of people there if anyone's looking for that kind of thing. I mentioned I have a newsletter, and that's enough self-promotion there. So one of the things I like to do when I have live talks is ask people if they have any questions up front, and then I kind of make a list of them, and I make sure at the end that I covered them all. And for the last 2 years, I've been mostly like just doing presentations to my computer, and there's no way for people to easily ask questions. So since you're all here, and some of you I know have probably seen this talk before or used clean architecture already, does anybody have any questions up front that they want to actually ask? Yeah?
Is there a good way to test, that your events are firing off?
All right, so the first question is there a good way to test that your events are firing off? That's awesome. I'll be sure to cover that. And Jeremy? Clean architecture in microservices, just like how to do it, or should we use it, or?
Yeah, kind of should you
and what not to do. Should you and what not to do. Okay. Anybody else? I'll try and remember those. Testing events, clean architecture, microservices. Got it. All right, I'm going to start with a couple questions myself because this is not my first rodeo, and I know that it won't be enough if I just ask y'all. So the questions that I'm going to try and answer in this talk include things like, why do we separate applications into multiple projects? We're going to see that the way I structure things for clean architecture uses multiple projects. You don't have to use multiple projects to build an ASP.NET application, but it can offer some benefits. And many companies do use multiple projects. I have a client I'm working with right now has a solution that's got 56 projects in it. That's probably more than you generally would need. But it can be beneficial to have a Goldilocks number of projects that's somewhere between 1 and 56. And I've seen bigger ones too. It's just crazy. Also, if you are going to split things up into different modules, projects, assemblies, what have you, what are some principles that you might use when you're making decisions about how to do that or where you should put what things belong in which modules? And when we think about how we organize our solution into different projects, does that have an impact on coupling? And we'll see also why is coupling important? Why do we care about that? And depending on how you approach this and which principles you do or don't follow, you might have some problems that result from certain approaches. And of course, clean architecture is the wonderful thing that's going to solve all those problems. It has trade-offs, of course, itself. Nothing is perfect. But we'll talk about how I use clean architecture in a lot of the solutions I build and what benefits I've gotten from it. All right? So let's start off with some principles that will apply. And these principles will help us sort of guide the way to the decisions that we make. So it doesn't just look like do this because Steve said so. These are some principles that are generally agreed upon. And you should be able to connect the dots and say, like, OK, I can see why we're using this principle to make this decision about the design of the system. All right, so the first principle that I think is most important here is called separation of concerns. And in this image here, which is a little bit blurry, but hopefully you can see it all right. It's showing a refrigerator. This is actually the Nimble Pros refrigerator that we took this picture with about a while ago. I think it was like in 2012 or something like that. And there might be some things in there that you don't typically find in your refrigerator. And the idea is that in your kitchen, you practice separation of concerns. You have certain things that are more like, plumbing or dirty or have to do with infrastructure, and other things that are more like high level, like what are we going to have for dinner tonight? And you want to keep those things in different places for good reasons. And so when we're applying this in our software, we want to avoid mixing different responsibilities in the same place, whether that's the same method or class or even project. Now, the big three that we're getting a preview of in my little Dr. Strange portal here are going to be data access, the business rules, or if you're using domain-driven design, that will be your domain model, and then any kind of I/O, including the user interface, whatever that is. If it's a web application, it's going to be your browser-based web app, or if you're building an API, it'll be the HTTP API. So those are the main three things that you want to try not to commingle together in the same class or method, et cetera. Right, closely related to separation of concerns is the single responsibility principle. And the single responsibility principle is the S in solid. It works very closely with separation of concerns, and it says that you don't want to have classes that are doing too much. You don't want to couple together different tools or different responsibilities in the same place. The reason for that is that it makes it more likely that you'll have to change that tool, or that some problem with some part of it, something that makes it not a good fit for your current needs, will have a negative impact on the thing you're trying to do. Much like if you're a general contractor, even though you could just have a Leatherman or a Swiss Army knife and have that be your one tool you use for everything, generally it's better if you have a bunch of fit-for-purpose tools. You'll be a lot more effective at your job. And if you happen to break or lose one of those things, it doesn't impact all your other tools. And so that's as far as I can carry that metaphor. So in the concept of software development, when we're talking about responsibilities, you can think of them as a reason for the code to change. And if we are able to separate our classes so that each one only has one reason to change, then that means that each one of those changes will have less impact. Right? The only thing that will be impacted when we have to make a change to that class will be the things that depend on that specific responsibility, because that class only has one. Whereas if you have a God class that has 100 different responsibilities, if any of them change, then all the different clients using any part of that class now are being impacted by that. The blast radius of the change is much larger. The scope of what you must test in order to verify you haven't broken anything is much greater. So single responsibility helps us limit the impact of changes and also makes things much easier to test, which is another great side effect. And then one of my favorite principles, and one that we put in just about every one of our software craftsmanship calendars, which is where these images come from, is the don't repeat yourself principle. And it wasn't lost on us that people noticed that we repeated this principle in multiple calendars. But the idea with the dry principle is that you don't want to have the same concept in multiple places in your code. Now, you have to be careful with this because it is very easy for you to introduce coupling when you have coincidental duplication in your software and you decide to eliminate it and replace it with an abstraction or a method or whatever it might be that now couples two unrelated concepts to that same thing. You'll know that you took this too far when you have a function that you put in place to get rid of duplication that now has a bunch of conditional logic that says, well, if I'm being called from here, do this, and if I'm being called from there, do that. Right? Now you've just coupled things together and probably added responsibilities when you shouldn't have. Right? That's an example of coincidental duplication. But when we have legitimate duplication where it's like the same exact concept in multiple places, that can cause problems because if we change it in one place and we forget to change it in the other, now we have inconsistent behavior and it's going to turn out to be a bug. So we want to refactor repetitive code into functions, and we want to organize these things. So we'll take those functions, we'll group them into cohesive classes, group those into folders and namespaces using whatever makes sense to us, group those into projects. And that's generally the way most people build software, especially in the .NET ecosystem, is using some type of organizational structure like this. Maybe the one that comes out of the box where Microsoft says you're going to have a folder for controllers and views and whatever, or you've got feature folders or something else that you found to be more effective. One thing I notice in a lot of the clients that I go to help is that that's the only level of separation or encapsulation that they have is basically you've got code that's encapsulated in a function that's got local scope to that function, and then there's a class that contains that function, and then the next thing up from a class is the whole project. And there's nothing in between. So Some other things that we don't have time to cover in this talk, but that you might want to think about as in between a class and a project level of encapsulation are aggregates, which you can learn about if you learn about domain-driven design. It's a key design pattern there. Features, I mentioned feature folders. You can use those as an encapsulation boundary as well, depending on how you design them. It's often a better way to design the system and organize it. And bounded context, which are another domain-driven design concept. So those are things you can explore if you're interested. Okay, and then the other principle that is important here is the dependency inversion principle. So we're kind of hitting both ends of the solid principles. This is the D in solid. And the idea here is that you don't want to couple directly to your low-level dependencies, the low-level things that you need to work with. In your house, you have probably electrical outlets. Those electrical outlets all have a common interface based on where you live. And all the appliances and other things that you want to get electricity have a plug that fits that interface, and you can just literally plug and play things in your house in order to get electricity. If you want to move the lamp across the room, it's generally not that difficult to do and doesn't require calling an electrician. However, if you just hardwire all your stuff to the wires in the wall, it's going to be a little more expensive, and it's also going to be a lot more inconvenient when you want to switch out what thing is wired where. So in our software, the idea with this principle is that your high-level classes and your implementation detail classes should depend on abstractions. And when we're talking about C#, we usually mean interfaces. Could be an abstract-based class or something else, but generally interfaces. Also, we want our classes to follow the explicit dependencies principle. And the explicit dependencies principle goes hand in hand with the dependency inversion principle, but is not as famous. Because it wasn't one of the original solid principles, it was one I made up. And the idea with this is that if you're following this principle, it means that your services, your classes that do things are asking for any of their dependencies in their constructor. You can think about this like a recipe, where if you ever cook and you see a recipe, you haven't done it before, you think it sounds good, there's a pretty picture of what the food's gonna look like, so you note the list of ingredients, you say, okay, this is good, I need these things, I've got those things, you run to the store, you grab what you need, you come back, and you're ready to make the recipe. And you're pretty confident in your abilities, you've got a fully stocked kitchen, you didn't read the entire recipe before you ran and got the ingredients, who has time for that? You just made sure you had the things that you needed. And you start going through the recipe, and then in the second paragraph, where it's like partway through, it's like, okay, now add the 6 potatoes. And you're like, there were no potatoes on the ingredient list. I don't have any potatoes. You know, now I have to go back to the store. Now dinner's going to be late. Oh, we'll just order pizza. And it's a surprise to you because you expect all the ingredients in a recipe to be listed up front. Right? This is how your classes should behave as well. All the things they need in terms of dependencies should be listed up front in the constructor. That's where the list of ingredients goes. And when you're explicit about these, you're not going to hide dependencies inside the code that developers will only encounter at runtime when they go to wire up your code and call it, and then suddenly are met with some dependency that says, oh, I need this file, oh, I need this web API, I need this database. Be upfront about the fact that you need those things. Be explicit with those dependencies. The other related thing to this is as we depend on abstractions and as we invert these dependencies, we want to make sure that the abstractions that we're using are accessible somewhere. And so they need to be accessible to the low-level implementation services. They're going to implement those abstractions, so they have to have the ability to reference them. The high-level business services are going to use these as well. Not so much implement them usually, but use them. And they may also be the things that are being returned by the interfaces. So your interface might return your business entities. So there's almost a two-way relationship between your domain model and your abstractions. And the entry point to your application is generally where you stitch all these things together. It's called the composition root. And if you're a .NET developer and you've been doing .NET Core for a while, that's going to be your configure services method in startup. Or now that they've gotten rid of startup, it'll be that place in program CS where you do that stuff. Okay, so let's look at the difference between coding with and without abstractions. So when I started programming, I didn't know anything about abstractions. I knew how to write code that used classes and called methods. And so I would write code that looked pretty much like what you see here on the left, where at compile time, my strongly typed language would compile and verify that the class that I was newing up existed and the function I was calling had the signature for the things I was passing to it. And I got everything compiled, and then I could run it, and the runtime flow would match that exactly. right? I said, you know, enter the class in public static void main, new up class B, call some method on it. Inside that method, I new up class C, call some method. And if I hit the debugger or I you know, see a stack trace where I'm inside class C, I see it's exactly the same flow, right? The dependencies and the control flow are identical. When you start to use abstractions, though, you can break that. And I didn't know that, you know, when I was a junior developer. It wasn't for a while into my career that I realized that you could do this. And you could say, actually, no, at compile time, we're going to depend on an interface. And at runtime, that could be anything else. And you can totally break that and not have your code be deterministic from how you wrote it, right? Your code could be different every time you run it based on how you stitch up the different dependencies, based on which appliances you plug into the outlets. And so it makes it so you have a much more flexible model. The other thing that this provides you with when you start to use these abstractions is the ability for you to write better tests. Michael Feathers has a great book called Working Effectively with Legacy Code. He talks about seams. Seams are places in your code that you can, you know, kind of break it apart in order to take a piece out and then test it in isolation. When you have code that's tightly coupled like this, where each thing news up the next thing, there are no seams. It's very difficult for you to inject something in there and test something without all the things below that it's newing up. But when there are interfaces involved, every one of those things can be tested all by itself. It makes it much easier to unit test your code as opposed to having to write more brittle and slower tests like integration tests or full UI or tests like that. All right, so those are some background on things we want to apply with this architecture. The other thing generally with architectures for software, not talking about like the server side infrastructure stuff like how it's running on Azure, but the architecture of the software piece of it, is that you want to make it so that it makes the right thing easy and the wrong thing hard. If you have software as an architecture or as the way it's built that developers are constantly having to read the documentation to see how it works, so they've got to read comments that say, remember, do it this way, don't do that, it's going to be more likely that you're going to have bugs because developers will forget things, right? We're only human. We can only fit so much in our brain at a time. And even the most disciplined developer is going to miss stuff. And we have tools that help us. We have compilers and tests that will help us, you know, if we forget something like a semicolon, the compiler's right there to say, Steve, you forgot the semicolon. And so that's one of the ways that we're helped. But our design can help that as well. We want to force developers into the pit of success so that if they are just, you know, on autopilot doing their thing, it tends to be the right thing. All right, so some of the ways that we can do this in our design is if we want to make sure UI classes don't directly depend on the infrastructure, the plumbing code, how can we structure the solution to help enforce that? And then likewise, the business classes shouldn't depend on infrastructure directly. So what does our solution design do to try and enforce that, and try and help developers with that? We talked about the DRY principle, don't repeat yourself. If we have a lot of repetition of query logic, validation, error handling, the ways we do stuff like that, is there a way that we can have that be easier to apply to the whole system, the whole application, than copy-paste, right? Which is a high bar, right? Because copy-paste is really easy. And so to make something easier than copy-paste is a challenge. But we can do it if we think about, you know, different ways to structure the system. All right, so let's look at one way that a lot of us build software or have built software, and it's what I call this sort of classic or legacy end-tier architecture. And this was actually the type of architecture that was considered best practice by Microsoft. My very first conference talk in 2001 was on using end-tier architecture. It was in September of 2001, so there were like 6 people there because nobody wanted to get on an airplane because of something that happened on 9/11 on that year. So I didn't have as big a room as this, but I do remember that conference forever because of that. But I had this slide in it, and this slide was, you know, showing you how you could break up your ASP page or your VB6 code that was all things in one place and split it up into these different layers. And you got benefits from this, right? You would have the ability to have different teams work on different pieces. You could have one developer focus on the data access layer, another one do all the business logic, someone else build the UI. You know, it had a lot of benefits. But all of the dependencies in here were tightly coupled, right? There were no abstractions. And so what you had was the data access layer at the bottom depended on the database, and each one above it depended on the next one below. And the problem with these is that these dependencies are transitive. So when you start trying to test the business layer, it talks to the data access layer, which talks to the database. And so you're still testing through the database. And even if you test at the UI level, basically everything is depending on the database. And I didn't know any better. I wrote software like this for a good while in my career. And I started getting into the idea of unit testing and was trying to unit test this stuff. And it just got more and more painful because of the fact that you had to reset the database state every time between tests. You had to have this big long script that would set the database to how it needed to be, and then every time you changed anything, if you like, oh, I need to write this new test, oh, it needs a new row in this table, okay, got it to work, but these other 5 tests just broke because they were expecting the previous number of rows in that table. And so it was problematic, and we have some better tooling now than we had at that time for dealing with integration testing with databases, but it's still not as nice as unit testing. So there is a different approach, and it's what I call domain-centric design. And the idea with this is that you put the business model at the center of the entire structure. And so your domain model is your business logic and also the things that represent items in the solution. So that's not just the logic, but also a sort of model of the problem space that in domain-driven design is made up typically of entities, interfaces, services, maybe value objects, aggregates, domain events, other things, which we'll see. Importantly, it also has the interfaces that define how to talk to the domain model. So if you have some thing that needs to get back a list of customers, there will be an abstraction for that, and it'll be in the domain model. Then everything else in the application, including all your infrastructure stuff, will depend on these interfaces in one way or another. Either they will consume them or they will implement them. So clean architecture is just another name for an architecture that's been around for a while. There are slight variations between these, so it's not entirely true for me to say they're identical, but they're really similar. They're more similar than they are different. Onion architecture, which has been around since 2009, my friend Jeffrey Palermo wrote some blog posts about it that you could Google. The hexagonal architecture, also known as ports and adapters, preceded that, and I think was late 90s, early 2000s. Here's a diagram that shows ports and adapters. And because the graphic artists that put this together decided to use hexagons for the domain model and the center of this, that's, as far as I know, how we came up with this hexagonal architecture. They could have used any shape they want. We would have had like, star-shaped architecture or whatever. But they used hexagons, so here we are. So in this model, at the center, you've got the domain model, just like in onion architecture and just like I described. And each of these little purple circles around the outside of that green hexagon represent interfaces, represent ports. And the way this works is that you plug in an adapter or an implementation into each one of those ports so that at runtime you can pick and choose which things you plug in, right? You want to talk to a database in production, like a real database, that's fine. In your tests, you want to just use an in-memory database or SQLite or something else, that's fine. Just plug in a different adapter for that. And it makes it so that your code is much more modular and flexible. Truly plug and play with this approach. And notably, all of the infrastructure information, all the dependence on the file system or the database is at the outside. Nothing is inside the domain layer. So that's one of the key rules of clean architecture is that the application core contains the domain model and all the other projects depend inward on that core project. That inner project defines the interfaces, and then the outer projects are responsible for implementing those interfaces. You also want to make sure that you don't have any direct dependency on the infrastructure project from other projects or other places in your code. Now, you might have it at the composition root in your UI, inside Startup CS or Program CS where you're launching the application. You may say that that's where you're going to wire up the interfaces to their implementations. But you can actually even get rid of a project reference there too if you really want to. I usually keep it, but there are ways around that. All right, we'll see the actual breakdown of things in a minute. So some of the features of clean architecture are that it's framework independent. It doesn't really have to be used with just .NET or Microsoft technology. You can use it with whatever language or platform you're using. It's database independent. A lot of the times when I write applications using this approach, I don't even have a database until I'm pretty far along in building the application, right? The database is sort of an afterthought. As I'm building the application, I can just use in-memory, whether I plug in some in-memory provider that's off the shelf or I just write my own. You can build a lot of functionality into the system before you ever need a place to store it long term. And so you don't care about the database. It's also UI independent. It doesn't really care what the UI looks like, again, because the focus is on the domain model. And the idea with the domain model, you're trying to capture the complexity of the business problem, of the actual problem domain inside of your model. Some other features are that it's extremely testable. One of the reasons it's testable is because the thing that makes unit testing or testing in general hard are direct dependencies on other pieces of infrastructure, right? Things that have side effects. I just went to Phil's talk this morning, and he talked about side effects in his Star Trek talk, and it's one of the things that makes testing extremely difficult. So you want to isolate the things that have side effects in your code and try and put them in one place that nothing else depends on, or as few things as possible depend on, rather than having it scattered throughout the application, or having business logic and data access mixed in with everything else in your application. Okay. So let's say you already have an existing app and you're like, great, Steve, this sounds wonderful. I'd like to do that. How do you refactor to a clean architecture system? Well, it's best if you're starting from something that's already organized the right way. And I have a template on GitHub. You can get a NuGet package that lets you just say .NET New and it'll create it if you like. There's other ones out there too. So if you search for this, you'll see a few variations on the theme. Next best is you have an application that is a single project. So everything is maybe organized into folders, but it's all just in one project. That's going to make it fairly easy for you to just move things to where they go in a clean architecture solution structure with different projects. The hardest one is when you already have a big investment in something that's got different projects, but they're organized the wrong way, right? You've got your UI depends on the business layer, depends on the data access layer, that classic n-tier structure, which a lot of software companies have right now. And now you have to reverse that. You have to figure out a way to invert those dependencies so that they don't go in that direction. And that takes more effort. Sometimes it's good to get help, or a lot of companies will just try and do a rewrite. That's somewhat fraught as well. But there's options there, but you may need to do more work. So it's definitely the more difficult approach. Okay. Now let's talk briefly about what goes in each project. So you've got a core project. This is your domain model. So what does that mean? What actual things go there? And what would we, if we looked at our code and all the different types of classes and things we have to build, what do we put in each place? Well, the first thing that goes in core is going to be most of your interfaces. All of your interfaces that don't reference infrastructure or some type of UI technology should generally go inside of core. And along with that, there's going to be the parts of your domain model. So that's going to be your entities, your value objects, your aggregates. An entity is just anything that has an ID property that you use when you're storing and fetching it from persistence. So almost every software application has some of those at least. Value objects and aggregates you may not be using, but they can be helpful to kind of better organize the code inside your model. Domain services have business logic that doesn't belong to a particular entity. Maybe it interacts between a couple entities, and these, again, are at a high level, right? They're implementing high-level business logic. They're not doing low-level work like deciding the format of how to serialize something to a file. And so they belong inside the domain model as well. You may have custom exceptions. I'm a big fan of domain-level exceptions. So instead of allowing your domain model to throw a null reference exception, it's better if you have a higher level exception that's customer required exception or something like that. So that a developer that sees that in the logs can very quickly isolate where that is, whereas if you have a null reference, sadly it doesn't generally tell you what was null, and you're left with some scavenger hunt to go figure out what the problem was. Make your future self or whoever's coming behind your's job easier by using custom exceptions that say exactly the thing that was wrong in the language of the business model. The other thing I'm a big fan of as a pattern is domain events. If you're using domain events, they belong inside the domain model too, which is going to be in this core project. One of the things domain events lets you do is separate when something happens, then this other stuff happens, right? And so if you have a method like shopping cart checkout, and when you check out from the shopping cart, we need to create a new order, charge their card, check inventory, send an email to them, send an email to the shipper, do this, do that, and there's like 10 different things in this complex workflow. If you have a checkout method on some object and it does all of that, right, that's doing a lot of responsibilities. And you're going to constantly be changing it in all likelihood because something else and something else is going to come along. It's like, oh, wouldn't it be nice if after they check out, we also do this and we also send this thing. And so if you use events, what it lets you do is have the checkout method on the basket or whatever, just do the state changes on that entity and fire off an event, basket checked out. And that's it, right? And it's done, and you'll never have to touch it again. And all the other follow-on activities go in event handlers. And you could have one event handler if you want that does a bunch of high-level stuff. You could have a bunch of smaller ones and run them in some sequence, however works for you. But it is a great pattern for taking stuff where the customer requirement is saying, hey, when this happens, then this should happen. Right? If you ever hear that from your client, think I can maybe use an event for that. And look into domain events if you haven't before. Event handlers then would also be part of the domain model frequently, although you might have event handlers also at other levels. In my DDD course example, we had event handlers that were at the UI level that were responsible for firing off things through SignalR to update the UI with little toast notifications to say, you know, this record was updated. And they just used the same infrastructure of an event handler that the domain model was using. The other thing you might have in core are specifications. This is another pattern that DDD uses a lot. You don't have to use it with DDD. The idea with a specification is that you're taking a query. In .NET developers, typically your queries are going to be link expressions that say .where this, you know, order by that, and things like that. If you're using Entity Framework, maybe you've got a bunch of things that are saying include this or not, depending on which endpoint you're working on or which page you're on. You want all the data or you just want a little bit of data, and you're having to shape the data by telling Entity Framework which things to include. Or which things to select and transform. All that logic that's having to do with the data is query logic, right? And that query logic is really a separate concern from the UI or from the business logic even in many cases in what you're doing. Often it belongs in your data access layer, or if it's high level enough, it belongs in the business model. And so what specifications let you do is take those queries in all their detail, including which columns I want, which rows I want, you know, with the where clause, whether I want to cache it, how I want to page it, you know, do I want to include these related things or not. You can take all that, put it into an object in your domain model that has no dependency on the database or on Entity Framework or on anything else, and give it a name. Right? And then that name you can reuse everywhere. So inside your code, instead of a bunch of link stuff that's copied and pasted in many different places, you can have a set of specifications, a library of specifications that you can use anywhere you need them, and they have you know, obvious names so that you can, you know, talk to other developers and say, yeah, use this specification in that place for that thing. In that way, they're similar to stored procedures, and, you know, in that they have a name and it makes them reusable and easier to find and take advantage of. But unlike stored procedures, they're actually in your C# code, so you can better version control them. Yes, you can version control your database, but it's easier generally in your C#. You can better test them. Yes, you could test your stored procedures too, but it's easier with C#, et cetera, et cetera. So specifications, if you're not using them, you should check them out. I have a NuGet package that makes all the things I just described work. So play with that if you haven't. Okay, so that's everything that's in the core project. Then the other project that's really important is the infrastructure project. The infrastructure project is where you wire in all those things that are talking to that ugly, nasty, dirty infrastructure stuff that our programs actually need if they're going to talk to anything else. So in here, if you're doing data access, you're typically going to have some data access services. These are frequently called repositories. Repository is another domain-driven design pattern. It's somewhat overused, I think, by folks, and a lot of people are writing blog posts to say repositories are unneeded and they're overused and they're all various problems. You don't need this because Entity Framework is a repository. Some people will say that. Don't believe them, because a repository is an abstraction that your domain model defines. Right? These are just the implementations of that abstraction. But if you don't have the abstraction that your domain model defines, then you're not using the pattern. And so in here, you can also do simple things like adding caching using the decorator pattern. So if you are using some kind of data access service, whatever you call it, you can create a decorator for that to add caching, which will, you know, add huge amounts to your performance if you have a very often reused piece of data access code. All right, so then your web API clients, if you're a consumer of other APIs, would also go here. Anything that talks to the file system, things that are doing logging, if you're implementing your own logging adapters, they might go here. Sending email or SMS, you know, if you're using localhost SMS or you're talking to SendGrid or Twilio or what have you, you know, those adapters would go here instead of you just hard coding them inside your code somewhere else. System clock is often something you want to wrap as well. If you are just printing out the time or storing the time, then you probably don't need to worry about that. You can just use datetime.now and be happy with that. But if you are putting in logic that depends on the time, and you're saying, well, if it's between 9 and 5, do this, but otherwise do that, then good luck writing a unit test for that that's going to work at any time. Right? And it's not really fun to try and change the system time of the machine the test is running on from inside the test in order to change the test. It's easier if you just have some abstraction where you can say, well, for this test, the time is whatever. All right, and so that adapter would also live in infrastructure. And then you might have other services and even other interfaces in here. Why would you have interfaces inside of the infrastructure project? Well, you may be working with some SDK like Azure or AWS or something else, and in that SDK you want to build some service that kind of acts as a facade or an adapter in front of it, but still returns or accepts types that are defined for that SDK, right? So if you have some method call that's going to return I don't know, a SQL blob object thing from Azure Storage, then, or not SQL, but just a blob object from storage, you can't put that inside of the core because it breaks the rules, right? It means now you have to depend on the Azure SDK in order to use that blob object type. So you can put those services inside infrastructure because they depend on those third-party types, okay? And since this is an ASP.NET Core talk, the next thing I would typically call the web project, or if it's strictly APIs, I might call it an API project, but it's the place that is your ASP.NET Core application or project. And in here, you're going to have all your web stuff, all the things that make ASP.NET Core work. This might be controllers and views. It could be Razor pages. If you're using the latest ASP.NET Core 6, you might be using what's called minimal APIs, where you don't even need to have controllers. You'll have various DTOs defined in here, typically. You might call those DTOs. You might call them view models or API models or binding models. I prefer to name DTOs in an intention-revealing way rather than just calling them DTO, so that developers know if they're using it and they're using it in a place that doesn't sound like where it's supposed to be, that's a hint, right? Like, oh, I'm using this view model class inside of my domain model. Like, that's not really where that goes. And it says right in the name it's a view model, so like it kind of tells you. Whereas if it was just a DTO, you might be like, oh, it's a DTO. I'll do whatever I want with it. You also have things like filters, binders, tag HTML helpers. Those are all ASP.NET MVC things. And so they would belong in this web project as well. If you have a lot of web projects and your company wants to share some of these things, then they would go in a NuGet package that only this project would consume. They wouldn't be consumed by or referenced by the core project. Sometimes it's worth referencing web stuff from infrastructure, and that's fine too. You might also have other services or even interfaces. These follow the same rules as infrastructure, right? So if you have a service that returns a view model, and the view model is defined in the web project, well, then the service can't live in core or infrastructure because that's not the way the dependencies work. It wouldn't compile. And so those services need to live here with those web types that they're using. All right. Now, most companies have more than one solution or application that they're building. And so if you have different solutions and you want to share code, there's a bunch of different ways that you could do that. You could just copy paste, which doesn't tend to scale too well. You could use, if everything's in the same source control repo, you could use shared libraries where you just have a folder with all the different libraries are in there and your solutions just pick and choose which ones. And you might have some that are in many different solutions. The problem with that approach is that if you make a change, it's a good and bad thing. If you make a change, the next time somebody gets the latest from the main branch that has that change, if it's a breaking change, you just broke them immediately. And that's good, because you'll find out quickly when you break things. But it's bad, because if that team was using continuous integration and continuous delivery, and they're trying to ship something like today, now they have to stop, they have to wait, they have to go fix that change before they can move on and deliver. So if you're trying to have a bunch of different applications that can all deploy independently from one another, it's better if those shared dependencies are as versioned packages. I'm a big fan of using internal NuGet feeds at companies where they have versioned dependencies that various things want to share. And so the shared kernel term comes from domain-driven design. The idea is that different bounded contexts agree that these parts of their model are shared between them. And in practice, what's supposed to happen is the developers on those teams will agree to any breaking change that's going to happen. Right? I know in a lot of companies that isn't necessarily how it really happens, but that's what should happen, is all the teams that depend on this dependency get in the room and say, yes, that sounds good, let's do that, that's to the benefit of us all. And nothing just gets added because somebody said so and breaks everybody. But more importantly, each team is able to decide when to take that dependency. So if team A needs some breaking change, they can add it, take the dependency on the new version of the package, but teams B, C, and D could still be shipping 5 minutes later because they're still using the previous version and everything's fine. If you're using microservices or trying to get there, one of the things that microservices are supposed to be is independently deployable from one another, and this is really important to get to that point. All right, so what goes in shared kernel might be base abstractions, base types for a lot of these things, like entities or specifications. Could be common exceptions or interfaces. Could be certain helpers for authentication or DI. If you're not using the built-in DI and you want to use something like AutoFact that has more features, you could put some helpers or things in here for that. Or what version of AutoFact you're using could be tied to the shared kernel. Common logging, common guard clauses could go here. Guard clauses are another pattern that I think aren't used as widely as perhaps they could, so I'll spend just 1 second to describe those. If you have code that looks like this, where you're checking inputs, which is good, you should be checking the inputs on a lot of methods to make sure that they're valid before you operate on them. Don't trust whatever's just given to you. That's a principle of defensive coding. However, if you write the code in this way with a bunch of else clauses, then the actual work that's being done in the method gets obscured. Right? This particular function only has 2 arguments, but even with that, you can see that there's a whole lot of cruft around the thing that you're actually trying to do, around the happy path of this function. So a guard clause is something that looks like this, where you just check for things up front and immediately fail if you don't have what you need. You can do this inside your constructors for things that are using dependency injection, if things might new them up without the appropriate dependencies. I don't do this religiously inside of like every controller because I know that the framework is going to tell me if ASP.NET Core can't satisfy a dependency. Right? We've all seen, if we've been building ASP.NET Core apps for a little while, where you try and run something and you have a controller and it says, hey, I couldn't resolve such and such interface. So I don't need to do all these checks in controllers generally. And I don't create controllers myself, right? The framework does. So I don't need them there. But my domain services that I might create anywhere, I do want to do these types of checks and make sure that I'm getting in the things that I need. Now, if you do this a lot, it turns out there's a lot of different ways to do this. There was a feature almost in C#11 that was going to add a double bang to the end of the variable name. So up here where it says order, it would be the lowercase order argument would have exclamation point after it. And if it were null, it would throw an argument null exception immediately, just as part of the C# compiler feature. That got cut, so it won't be in 11. It might come in another version later. But things like that, they're trying to make easier. There is an extension method on argument null exception that you can use to do this. And there's expression-bodied exceptions that you can do as well. Basically, there's a lot of variation on this. And you don't necessarily want a lot of variation in your code on how to do the same thing. Like different developers might all do it different ways. So it would be a good idea if you had a common way of doing it. So create a NuGet package or use mine that has a common way to do it, and all your code looks the same and it does the same thing. And if you want to add anything to it, like logging or something like that, you have one place that you can go and do it. OK, so that's enough on guard clauses. So now let's talk about where we are with the whole structure. We've got this basically layer stack thing where at the very bottom, the thing everything depends on is the shared kernel. Now I mentioned that core shouldn't depend on infrastructure stuff. Shared kernel is being depended on by core. So it's even more important that it doesn't depend on infrastructure stuff, because if it does, it pollutes all the other solutions that are depending on it. And then you've got the core for a particular application, a particular bounded context, maybe a microservice if you're doing those. And then web and infrastructure each depend on core, and that's how all the dependencies flow. Now, you'll notice there's a missing arrow here between web and infrastructure. So at runtime, the entry point for the application is going to need that infrastructure stuff. Like, how is it actually going to talk to the database? How is it actually going to read a file? All that logic for the plumbing code is in infrastructure. So normally, you'll just have a project reference, and you'll say, web project depends on infrastructure project, and that's fine. Now, if you do that, though, that means that any developer that wants to, inside any web class, can just new up something from infrastructure or even ask for it through dependency injection and kind of break the rules and pollute your nice, pure, clean architecture design. So I use a light gray arrow here because it's actually an optional dependency. If you want to, you could make it so there is no project reference, but every time the infrastructure project compiles, have a post-build hook that just copies its DLL into the bin folder in the web project. And then when the web project starts up, it can use reflection to load that and still do all the wire up of interfaces to implementations. If you do that, then developers won't be able to compile any code in the web project that references infrastructure types. And so that's an option. I don't recommend it for most teams because it's a little bit overkill. But if you really don't trust your developers not to go and grab things out of infrastructure and depend on them in the web project when they shouldn't, it is an option for you. OK, so then around this, we want to add some tests. And like I said, I'm a big fan of unit tests. So unit tests are going to be most beneficial on the core project because it doesn't have any dependencies. By definition, unit tests should not touch anything that isn't your code. Right? So when you try and write a unit test that actually talks to the database, then by definition now it's not a unit test anymore. It's an integration test because it's doing more stuff like talking outside of your process. You could also write some functional tests for the web project, Functional tests are just what I call integration tests that kind of test the whole functionality of the system. They still run in memory in ASP.NET Core, and they're very fast. Not quite as fast as unit tests, but they're close. And they exercise the whole system, usually with like an in-memory database and things like that that you wire up for it. And then you have integration tests for infrastructure stuff, just to verify that it really does write to a file. It really does talk to Azure or Amazon. And so that's generally what you have. You could write unit tests for some of those other things too, and that's fine. But the bulk of your integration tests are going to be for infrastructure. The bulk of your functional tests will be against web, and then mostly unit tests on core. And so with all of this, your basic folder structure ends up looking like this, where you've got your core, infrastructure, and web projects. Shared kernel kind of comes out of the box in the template as a place to put stuff. But the very first thing you should do if you use the template is rip that out and put it in its own solution and build it and publish it to your internal NuGet feed, and then just add a NuGet package reference to it from your core project. And then in this also you have the test. So all told, this says 7 projects. Really it would be 6 because you wouldn't have the shared kernel in here. And so you'd have 6 projects per application. Now some of you may think, and I know people online have said, that's total overkill. You've got way too many things going on here. But one of the things that this buys us, this separation, is that dependency inversion principle and the ability that protects us from accidentally doing the wrong thing. It's forcing us into the pit of success. Now some folks will say, well, I'm the only developer on this and I trust myself, I'm not going to do things wrong. And I say, that's fine. So I'm sure you're not using any keywords like private or protected because you don't need those. You can just make everything public. And in fact, you could probably just use globals for everything because you don't need any encapsulation because you know what you're doing. And so you can do everything just with global. In fact, you don't even need classes at that point. Just do it all as procedural code. And if you want to do that and you're disciplined, good programmer that you are, feel free. You'll be great. But that's not how you typically want to build things in an object-oriented system like C#. You're not taking advantage of the language at that point. Okay, so how are we doing on time? We got about 15 minutes. All right, so let's do some walkthroughs. So one of them I'm not going to walk through right now, and it's hard to read that because it's black, but there's this eShop on Web reference application that uses the same architecture, has a few minor variations from my template. It is a full application that you could look at. It's a storefront that is a Microsoft published reference architecture. So you can see the URL is .NET architecture, and it's an actual Microsoft-owned GitHub repo that you can look at to see examples of how this stuff works. The one I am going to show you right now is this Dallas clean architecture template, which again, if you want to, you can install it as a .NET new template. And then when you want to create one of these, you just say .NET new and then your company name, application name, and it will create this thing with all the right namespaces and stuff for you. So you don't have to go through that tedious process of renaming all the namespaces to match your company. So let's go ahead and take a look at that real quick. And let's see if I can get the screen to share. I think I have to stop my slides. So we'll do that. And I'm on slide 64 if I need to get back there. All right, so this is the clean architecture sample. And inside of core, because this is a template, right? It's meant to be a solution template. One of the things I've often lamented that Microsoft doesn't have is any kind of solution templates. They only have project templates. So when you want to create one of these things that involves multiple projects, you had to do a lot of work to create each one and name it and then set the references and et cetera. And what is the Windows magnify? Is it Windows M? Somebody know? It's not that. No, that wasn't it. Windows Plus, thank you. I was about to get there. So let me just zoom in so you can see this a little better. All right. And so in here, because it's a template, it's not a reference application. It's not a sample app. So it has a very minimal amount of stuff just to kind of show you what might go where and how that might work. And so there's interfaces in here that you might use. There's this aggregate for a project, and a project has some to-do items. And so the project is the parent, the to-do items as the children. And when all the to-do items are done, then that means the project is done. That's kind of how it rolls up. And so you can kind of see how these things work. If you want to see specifications, there's some example specifications in here. So if I want to get the project by ID with its items, Windows Escape, yeah, it looks like this. So this is what a specification looks like. So instead of having those link statements wherever you might need them inside your code, you put them inside the specification. Now they're reusable and testable and well-named in one place, which I tend to find better than having data access query logic just scattered everywhere in your application. Another reason why you probably don't want to return iQueryable inside your data access layer, because then you'll end up just having data access logic scattered everywhere else in the code that uses that iQueryable. So those are specifications. These are using my Ardalis specification library, which has a generic specification of whatever entity that you inherit from. And then literally you just need to put this inside the constructor, and that's it. They can be parameterized, of course, so you can pass in whatever you need, and then they give you the query. There are domain events. So for instance, when we complete a to-do item, we create a domain event. A domain event should be immutable. It's a thing that happened, and so you shouldn't be changing it later. You just give it whatever state might be useful to some downstream handler. In this case, when an item is completed, we just pass in that item. And then whatever handlers downstream want to do something about that, they have the item so they can inspect its state and send an email or do whatever they want to do. In this example, there might be event handlers. So when an item is completed, I want to send an email, for instance. And so this would be an example of a domain event handler. And it sends emails, but it doesn't know anything about how to send email because it uses an interface. Right? And so this email sender is defined inside this core project as an abstraction. And then in here, I just have whatever logic to send the email, like who am I sending it to and what should it be called. And if I wanted a template for how I'm going to send emails, I'm going to use some fancy template, then I might have a template service that I would also ask for here. Now, the really nice thing about this, and something a lot of people struggle with, is that these domain event handlers can use dependency injection, right? They can ask for whatever they want, whereas your entities typically can't or don't. And so when you complete an item, you might have a to-do item, and in here, it has this method called mark complete. We don't just expose the property and let you set whether or not something is done here, because then we wouldn't have a way to respond to that easily. Right? We could put a bunch of logic in the setter, but that's not typically how we write code canonically in C#, in my experience. Right? Some of you may do that. I think it's better if you have well-named methods for certain operations that your domain objects are exposing. And mark complete is more clear and high level than set is done equal true, even though they both do the same thing. Because I have this well-named method, I can then check if it's not done, then mark it as true, right? Because if somebody marks something complete and it's already complete, I don't want to do more events, right? Nothing really happened there. In fact, I might even want to throw an exception if I didn't expect that to happen. But in here now, I can just add this event. And what the event does is it just goes into a queue, a list, inside this base entity type. It has a list of those events. And then when I persist this event, when I persist the to-do item entity in its new state, I say, look, I'm going to save this thing now in the actual persisted database. The is done is now going to be set to true. Then after that, I'm going to fire off all these events. And the reason why that's important is because if I fire off the event right here, right now, immediately, before I save that, I might inadvertently do something wrong. Like if this were a shopping cart and I was checking out, and I said, OK, right here, fire off the event. And the first event says, tell the customer that their order's on the way. Right? And then I go to save, and the database connection is not working, and it just forgets and blocks and accepts, whatever. Right? It doesn't work. Now I'm in this weird state where the customer got an email saying their order's on the way, and our database doesn't have the order. And depending on how good we are at doing retry logic or splunking into the logs to find that problem and then recreating their order somehow, right? They may send us an email a week later and say, I didn't get my order. Look, here's my email. And you're like, we don't know about this order. Where'd that come from? So to avoid that, we don't want to do domain event handlers that would have external side effects, which they often do, until after persistence. And so the plumbing for that is all in here as well. So that happens inside the infrastructure here. Inside, in this case, it's using entity framework, but you could use something else if you want. Just use the same ideas. And then in here, when we go to save changes, it just saves changes. If there's a problem there, it will throw an exception. If it throws an exception, it's not going to do anything else in this method. Right? And so then if it didn't throw an exception, it's going to get down here. It's going to grab all the entities that have events. It's going to loop over all those events, and it's going to publish them. In this case, I'm using the popular library Mediator to do that work. But you could use something else if you want. I used to have my own custom domain event dispatcher, but Mediator's so popular now, I was just like, I'll just use that. And so what that does is it just dispatches those so that if you were debugging through this code, you would see the call to the handler would happen right here after the call to save the record has succeeded. All right? So again, to recap the benefit of that, if I come back here, a lot of times what I see is developers get to code like this, and they have been told, they have learned somewhere that you should have non-anemic domain model entities. Right? You should have logic in your entities. They shouldn't just be a bag of getters and setters and properties. They shouldn't just be DTOs. And so as soon as you get to some logic like this where it's like, oh, when someone marks this complete, I should send an email. Well, they're either stuck doing like, okay, right here, static call to send email helper, which now makes this coupled to that static thing that makes it hard to test, and now we're coupled to infrastructure, and that's just evil. We don't want to do that. Or they'll say, I'm stuck, this is impossible, there's no way for me to do it. I'm going to rip this out. I'm going to create a to-do item service, and it's going to have a mark complete method, and I'll pass in the item that I want to mark complete. And then the service can use dependency injection and fire off emails. Anybody ever do that? I've done it. A few of you? Yeah. So domain events is a way out of that. Because when you go down that road, eventually it leads you to this anemic domain model. Why? Because your nice domain model here has a bunch of nice methods on it. Pretend it's got 5 other methods besides this one. And suddenly this one needed a dependency, so you moved it to the to-do item service. Right? At the next higher level in your controllers, your API, people are consuming your model. And in a lot of places, they're like, okay, give me this item and call these methods on it and then save it. And that's great. And then in this one place, they're like, oh, I can't do that anymore. I have to go ask for a service now and then call some method. And to them, they don't look any different. Right? Why does mark complete need a service, but mark invalid doesn't? Well, because mark complete sends an email, and that one didn't. And they don't know that. It just looks like it's not consistent anymore. So eventually, what do? Well, to make it consistent, you rip everything out of the entity, and you put it all on the service, right? Because you can't go the other way. And now you're going down that path to having an anemic domain model, which is bad. So by doing domain events, you escape that trap, and it makes it so you can still have all your logic in your domain model and have dependency injection for follow-on events. So it works well for that purpose. All right, so I have about 4 minutes left. I want to show one other quick thing. This is a different library. This is API endpoints. If you're building APIs in ASP.NET Core, how many of you, show hands, who's building APIs? All right, who's building web forms? One person in the back, I'm sorry. Yeah, the web forms are great. I made a lot of money and made a lot of applications with web forms, but today I'm much happier building web APIs, and almost everybody's building SPA applications with React or Angular or Blazor maybe, or mobile apps, right? And all those things need APIs. So APIs is what a lot of us are building today. And if you build APIs with controllers, what you end up with are these giant controllers that don't follow a single responsibility, and they have way too much stuff in them. And then if you use the default organization, you maybe have a controllers folder and then a view models folder or API models folder. And you've got to kind of jump around between different folders to find all the things. Somebody says, I need to do endpoint to do X. And you're like, OK, I need to look at the domain model, and then I need to look at the view models folder, and then I look at the controller and find that method in that controller. And everything's not together. So if you use this API endpoints library, there's a sample here for it that looks like this. What you can do is just define each endpoint as its own thing. So in this example, I've got this author's endpoint. And one of the endpoints on the author API is to create an author. And instead of using the MVC pattern, this is using what I call the Reaper pattern, which is request endpoint response, REPR. And so for each one of these, you've got something that looks like this. It has a request, and it may have a response or a result. In this case, because it's just a create, it doesn't have any type of result. But let's look at, say, get, for example. So the request for a get would be an integer. The result would be an author result. Inside of this, it only asks for the exact things it needs. And then instead of having a different action method for every different thing, you just have one handle method that does the work. And so with this, you get, everything is well organized in this case. So the things that you need for this endpoint are right here attached to it in Visual Studio. If you're using VS Code, they're in alphabetical sequence. They're right with it there in the code, even if they aren't in a tree. But I find this to be a much nicer way to organize things. Now, this is based on controllers. So it's not like this whole big custom thing that replaces .NET. It's, at the end of the day, this base class that you're using up here, which has this really cool Fluent generics interface that I didn't invent. But it's still really nice so that you can say dot with request, and then you come over here and you can say dot with whatever, and you get IntelliSense for what kind of result you want to do all those generics. It works really nicely. And there's a link to the original author on the repo. But this I like a lot. If you are using .NET 6 and you really want to use their new API, minimal API structure, there is another library that's basically the same as mine, uses the same pattern called fast endpoints that I would encourage you to check out. It's by a GitHub person named DJ Nightshade. And so he's got really good documentation for it too, you could look at. But at the end of the day, the nice thing that I like about this organization is that your endpoints are each their own little standalone class. They have an appropriate name. All the types they need are bundled with them. And they only have the dependencies they need. Right? How many of you have controllers with half a dozen or more actions on them for APIs, and your controller has like 10 or more different dependencies? Anybody ever have a lot of dependencies on control? Yeah. And how many of those methods use all those dependencies? 0? Yeah. So you probably want to break those up, and this is a good way to do it. All right. So with that, I am out of time. I'm going to jump back to my, that's not it. I'm going to jump back to my slides, and we're going to do somewhere I've got this. Somewhere I've got some info, but we'll just throw that slide up and say thank you very much. I hope you enjoy the rest of your day at StirTrack. I hope this was helpful. All the stuff you need is here, and if you don't find something, just hit me up on email, Twitter, whatever. Okay, thanks.